Okay, so the basic idea is I would really like to use dev C++. That's the IDE I've been using for a lot of other projects, coding C++ for a long time. I have a lot of experience with that. I never switched over to one of the more popular IDEs, even though that's not maintained. I wouldn't recommend it, but it works great for me. So far, I've had no problems with it. I've created a 135,000 line of code program with it. Very sophisticated software program, and I've had no problems. I mean, it does crash now and then, but I save a lot. So that's my plan. I would like to just use dev C++, and my plan also is, so I'd like the robot to have an actual laptop with the keys, keyboard, everything not needed stripped, the LCD taken off. So just the motherboard of the laptop in its chest, and that will run Windows. So it's going to be a Windows operating system, and I like the idea of using a motherboard because then I'm able to use the Windows API for all networking, and I'm able to use API that I'm comfortable with. I've already been working with the Windows API for a long time, Win32 API, and I can do remote viewing of whatever the robot sees through that system. I know how to work with socket programming and file transfer protocol. I can set it up to auto update itself, so I can be on my personal computer coding, and when I want to update the code of the robot, I could just compile that. It'll automatically send a request to the server or to the robot directly that the robot is to restart itself. So it will shut down its program, download the latest compiled version of the program, and then relaunch itself, and it will have whatever changes I made to the program, so it will run whatever routine I want. Okay, so it's going to have a laptop in its chest, and then the laptop is going to connect to a 32-channel lynxmotion servo motor controller, and it's going to connect to that through a serial to USB cable. I'm going to have at least 4 of those. I anticipate I'm going to have close to 200 servos running in order to power the entire robot, but that depends a little bit on how many servos I need for the thighs to replace the thigh muscles, and how many for the bicep-tricep combination, the thigh-hamstring combination. I'm planning to use some bigger servos for that have a lot more torque, because it's amazing, the biceps and triceps actually have to generate about 10 times whatever the weight you have in your hand. So if your bicep curling a 5-pound weight, your biceps are actually lifting close to 65 or 70 pounds of weight to do that. About 50, maybe less than that, I don't know. About 10 times as much. So that'd be 50 pounds. But I would like it to be able to comfortably handle a good 10 pounds. So I'm probably going to use a couple 20-pound inch servos, like maybe 4 of them, to do the biceps. I'm going to need servos for every joint that moves. So that would be one, that would be one, that would be one. In the fingers, so I'm going to have like 50 servos just for all the fingers. Everything they can do, I want it to be fully articulated. Some people just have it do this, and then this, and maybe the thumbs can do this, and then the hand just spins in circles. I don't really want that. I want it to be as close to human, especially the hands. The hands are so important for it to be able to do fine tasks that involve the fingers. So I want the fingers to, I'm not going to take any shortcuts there with the servos. I put servos all throughout the arms and biceps, whatever it takes to be able to run those to make the fingers work correctly. So I'm going to have maybe 4 32-channel lynxmotion servo motor controllers, all connected to the laptop by USB, and then the laptop is going to be my central logic unit. So that will calculate where all the servos need to be at any given point in time. It will also calculate, let's say, advanced walking or planning the path of a hand reaching forward and grabbing something. It will actually animate that whole thing programmatically, and then frame by frame it will break it down. It'll take the first frame and it will calculate where every motor needs to go to from point A to point B to get to where that motor needs to be in order to get the body to move into that frame of the animation that it created. So I'll be able to create really nice, smooth, human-looking animations and then break that down with the software algorithms into frame-by-frame motions and where all the servos need to be to make that frame happen. The 32-channel servo motor controllers are not really having much logic, although my main software on the laptop will be able to ask them where all the motors are at any given point in time. So if one motor's maybe not performing up to par, maybe it will send it more voltage or increase the speed in the command for it to move. So maybe it can adjust it that way. Also, the resolution of the frames will depend upon the speed I can send the signal changes to the motors and how that works. And I don't know exactly how that will work. I've never worked with servo motors before. Okay, so the laptop will also be able to connect by USB to many different things such as GPS. Sonar chips can come that can be hooked up to one of the lynxmotion controllers by the analog port, I believe. And those are just a little chip I could put in the eyes. That could be nice. GPS I mentioned, a couple of webcams for vision. 2 webcams combined can create stereoscopic vision. I still haven't researched how that works, but I know it's supposed to be able to create depth perception, so that would be really cool if I could program that sort of thing. I could put speakers in the ears for voice recognition. So I want the robot to be completely encased in rubber so that it will look like skin and it will protect everything from snags, so it will look more realistic, and I want to even put clothing on it.